Welcome to Whiteboard Math. Today's topic is Gaussian elimination, which is also sometimes called the Gauss-Jordan method. Let's find out how it works. Gaussian elimination is a method to solve systems of equations. It uses modifications of the system without changing the solutions of the original system. In the end, we want to make sure that x1 is only visible in the first equation, x2 in the second equation, and x3 in the third equation. Let's have a look at this example. To solve this system of equations, we use the Gaussian elimination. To arrive at the correct solutions, we make sure to modify the system by using different steps, which are also known as elementary row operations. There are three different types of elementary row operations. 1. Interchanging different rows with each other. 2. Multiplying any of the rows by a scalar. And 3. Adding a multiple of another row to a different row. The goal of these elementary row operations is to make sure that the leading entries, which are x1 in the first row, x2 in the second row, and x3 in the third row, have a coefficient of 1. All entries below these ones must be 0. After that, we can solve the system of equations. In the example we use, we can see all of the elementary row operations, and I will make sure to mention them explicitly. The example is visible on your screen now. 2x2 minus 2x3 is 6. x1 plus x2 minus x3 is 4. Minus x1 minus 3x2 minus 2x3 is 0. As we have seen before, we can write the system of equations as a matrix. This matrix is on your screen now. Because there's a 0 in the first entry in the first row and a 1 in the first entry of the second row, it is best to switch them around. This is elementary row operation number 1. We interchange the rows. We end up with the matrix you can see on your screen now. You can see that the only thing that has changed is that the rows 1 and 2 are interchanged. Row 3 is exactly the same. The next step is to make a 0 from the first entry of row 3, which is now a minus 1. We can do this by multiplying row 1 and adding that to row 3. This is elementary row operation 3. You can see the new matrix on your screen now. The entries are the following. 1 times 1 is 1. If we add 1 to minus 1, you get 0. 1 times 1 is 1. If you add that to minus 3, you get minus 2. 1 times minus 1 is minus 1. If you add that to minus 2, you get minus 3. 4 times 1 is 4. If you add that to 0, you get 4. The next step is to make a 0 from the second entry of row 3, which is now a minus 2. We can do this by multiplying row 2 with 1 and adding that to row 3. We then get 0 times 1 plus 0 is 0. 2 times 1 is 2. If we add that to minus 2, we get 0. Minus 2 times 1 is minus 2. If we add that to minus 3, we get minus 5. And 6 times 1 is 6. If we add that to 4, we get 10. This is also elementary row operation number 3. Next up, we have to make a 1 from the 2 in row 2 and the second entry. We can do this by multiplying by a scalar, which is in this case a half. This is elementary row operation number 2. 0 times a half is 0. 2 times a half is 1, minus 2 times a half is minus 1, and 6 times a half is 3. The last thing we now need to do is get rid of the minus 5 in the third row and the third column. This has to become a 1. We can do this by multiplying the row with minus a fifth. The two zeros in the last row remain a 0 when we multiply with minus a fifth. 5 times minus a fifth is 1, and 10 times minus a fifth is minus 2. We are now ready to write the matrix back as a system of linear equations. You can now see the system of linear equations on your screen. You can see that x3 equals minus 2. If x3 equals minus 2, x2 minus minus 2 equals 3. This means that x2 has to be 1. x1 plus 1 minus minus 2 equals 4. This means that x1 is also 1. We have now solved the system of linear equations. Remember that instead of x1, x2 and x3, it's also very common to use x, y and z. We have now come to the end of the video. If you learned something today, please like this video and subscribe to my channel. This would mean the world to me. See you in my next video.